Hello everybody and welcome back. So we're going to continue and solve this problem. The problem is, as I told you, that in this point cache node, if we use the recommended property names, it will actually fix the position how to say it? Well, it's going to fix the position inverted for us, and it's going to fix the angle or rotation inversion for us, because it's left and right handed difference with Unity and Houdini. Because it's a bug when you do it like this, the color also gets inverted, and that's not correct, so we're going to do it manually. So we're going to do position, angle, and color. So we need to add angle as well. So we have, we know that it's supposed to look like this, right? So we have our reference. So when we export stuff, we're going to just have two different nodes to solve this for us. And one going to be a Wrangler here. So I'm just going to make this one here a copy one. This just going to be a debug. So this one going to fix position problem. Fix Unity, fix position Unity conversion, if that's spelled like that, I don't know. So here, the only thing we need to do is in the position .x, that's times equal -1. So we're only going to flip the x position. And if we see what happens, we see we kind of flip it like this. And we also need to flip the rotation as well. So in order to flip the rotation, fix rotation Unity conversion, I guess that's how it should be. So we need an angle for this. Because in here, in the VFX graph, we don't have rotation or quaternions or that orient. So if we do like this, spacebar, orient, no, rotation, no, we have angle. Here, update, set angle, that's what I meant. So we need the angle in here, and what we do have to convert an angle, like this. We can't just do -x or something. It's a little bit more complicated. So what we need to do up here, we have we fixed the forward. Well, we can say like this. The up represent forward. No. Of course, up represent up, and forward and normal represent forward. And because we have these ones, we're going to take in here fix rotation. So we're going to make a vector 4. That's going to be our orientation. It's going to be a quaternion. And we're going to make transform. And that's going to be our normal. And it's going to be our up. So what happened here? First we made a matrix. Then we just put it inside this quaternion function to make an orient of it. Actually, to make it more obvious, maybe we should do it like this. And then we did like this. I think it's a matrix free, I hope so. And then when we have this orientation, in order to flip to the correct one that the Unity have, we do orient is equal to set orient.x, orient.y, orient.z, orient.w. So this is the only says orient is equal same value as before. And to make it a little bit more clearer, I'm gonna make like this. So we're gonna, the I and Z, these two, I'm gonna negate those ones. And that's gonna make the angle be correct in Unity. So then we're gonna do, actually, first off, we're gonna do P at orient is equal orient. Now if we do the debug here, you see that the orientation is flipped, so it's fixed, right? So now we have the correct orientation. It is super nice, but we don't really need to store the orient. We're gonna export an angle, and we're gonna do a vector angle is equal to quaternion to Euler, and that's gonna be orient, and 0 represent, well, actually, when you do 0 here, it's instead of define these kind of things. So that's a rotation order. So we use X, Y, and Z. So yeah, that's why we have 0. And then we're gonna do the angle is equal to angle. And now the angles here are radians, and Unity want to read the angles in degrees. So we're going to do degrees, and this should be exactly what Unity wants. So if we do, let's see, we could as well just keep the orient to make this one look good. So the problem we have is that when we exported the old way, the color also was converted. And now we're gonna export and make sure everything is flipped, and we do it custom. So next time we export, the position's gonna be doing this way instead. So let's take it step by step. I'm gonna not fix the rotation. So it's gonna be, let's see, there's some error. Okay, we need this error does asking for angle. So we need to have it. So I don't take it step by step, but I do it at the same time. So here, now we have the position, and actually the angles are also exported. And it's super easy to fix this, and we just need to do we should box bridge. This is the one we're gonna look at. This is the one we made before. The other one was just Test. Okay, so here we have the sample point cache. And if it's supposed to add an angle. I think it's, yeah, we just needed to update the node so it's ready to go. So here we have the angle. So in update particle, we're going to do set angle. And if we do set angle and go back, now we have everything as we want it, and we have full control of the export. So if we take this ref and place it at 0, you see the ref is exactly the same as our points. So this is super nice. So now we could export stuff and we can expect it to be exactly the way it is. And we have full control of it. So let's see, we can, to make it a little bit more interesting, we can add a noise. So we move these things up and down. And it's super simple. We just do the time total time. We're going to have a noise. And we're just going to make a noise. Noise. A 3-dimensional. And we're going to have the get position. And we're going to add time with the position. So we get an animated noise. And we're just going to add this to the position. So if we do an add here and put it in here, and then we do a vector 3 here, and we're just going to put the I and add the I value together. Now you see we only animate the I. And it's a little bit too strong. So I'm gonna make a multiply here. So I'm just gonna make sure that the strength we're using is 0.1. So this is a super simple setup how to do this. And well, let's say you could actually do like this too. If you have, we have, so we only need, if we just make a copy, well, we don't need a debug anymore. If we just take everything here, and we do know that the scatter is always doing 121. Actually, we can do like this. Take the scatter, right-click, actions, create reference copy. We plug it here and remove the other one. Now we know it's going to be exactly the same amount of points on these two. And if we change this one to be point cache 2. Now, if we take this one and we change this one around, I don't know what to do. I just do something. And then we have these points being downwards. Well, actually, we just do. Let's see. This is the other one. And this one, we could just have it like this. So if we export these points, now we have 2 point cache. So if we, here we have the point count. So actually if we do the point count here, we have one less node. So if we take this one here, we have the other one. And let's say we want to lerp between those two. It's super easy. We just do this going to be here, keep this one here. This one's going to be down here. We're going to group them. This is going to be the noise part. And also we're going to have a float value. This is going to be transition. And this one going to be between 0 and 1. So this one going to be used in a lerp. So what happened is here that we gonna make a lerp between these 2 point sampled nodes. So we have the position, we have the angle, and we have the color. And we have the transition here. So we just add the position here. We set the angle to the angle. And we do the color to the color. So we have it like this. And also we need to add the new point. We have point cache 2 that needs to be on this one. And if we save it, and then we have this lerp here. And let's see, something's not working. We have the position, And we need also, you see here, we need this particle ID, so we read the correct place. So we save it. And now we can do lerp between those two. Cool, isn't it? So I really hope that you enjoyed this, and it's kind of the basics to make sure that we know how to import and have control over stuff, rotation and so forth. So I'm probably going to do another tutorial, a little bit more visual appealing than this one. So I really hope you enjoyed this one, and thank you so much for watching.